In this video, we're going to look at how to partition a segment. So what partitioning a segment means is it means that you're dividing a segment into different pieces and you're using a ratio to do that. So it's going to be dividing it up into any number of parts. So when we find the midpoint of a segment, we're dividing the segment into a 1-to-1 ratio, meaning the two parts on either side of the midpoint are the same and there's only one part on either side of the midpoint. When we talk about partitioning, you can break it up into any ratio. So like a 2-to-1 ratio, 3-to-1 ratio, 4-to-2 ratio. So different scenarios. So if we look at the first example, we're given segment AF. And what we want to do is we want to just come up with the points so that these ratios hold true. So we want to find point P such that AP to PF is in a 1-to-4 ratio. So first of all, look at the outside letters. That means we're dealing with this entire segment, A to F. We want to place point P so that we have 1 part to 4 parts. So that means if you look, we have 1 part here. That's where point P is going to go. So that then we have the 4 equal sections right here. So 1 part to 4 parts. So that would be how you would break that segment into a 1-to-4 ratio. If you look at the next one, point Q, again, the outside points are AF, so that means the entire segment we're looking at. And you want to find Q so that you have a 3-to-2 ratio. So that means you have 1, 2, and 3, and that's going to be where Q goes, and then you have 2 sections left. So it's a 3-to-2 ratio. And then the last one here, we have a 1-to-2 ratio. So B and E are the outside points this time. So that means we're really looking at from B to E, only this section, and we're breaking it up into 1-to-2 parts. So here's 1 part, that's where we're going to put point R, and then here's your 2 parts. So this is 1-to-2 because remember we're only looking at from B to E. So we're only looking at this section of the whole segment. So that's kind of the idea of partitioning. One other important idea here is the fact that a directed line segment means that the order matters. So when we talk about partitioning, we're going to be partitioning segments that are considered directed line segments because the order of the letters is going to matter. If we're talking about a ratio like 1-to-4, it means the order matters. The 1 part is going to be on the left side and the 4 parts will be on the right side. So you always read them left to right. So it's going to be really important to keep that in mind, that the ratio, the order matters. And when we look at a directed line segment, the order matters as well. So when we say AB, A is going to be on the left, B will be on the right. So let's try some examples on a graph of how you can partition these. How can you actually find the coordinate? So we start by looking at, okay, we have a line segment. We want to find the coordinates of P along this directed line segment. So that means the order A, B is going to be left to right, so that this is true. So that means we're trying to break this up into a 3-to-2 ratio, which really means we're breaking this up into 5 parts. So the first thing I always like to do is just sketch out a picture of what this is going to look like. So starting with A, we're going to have 3 parts. So 1, 2, 3. That's where point P is going to go. And then you're going to have 2 parts on the right side. And that's where point B is going to go. So when I say parts, I'm talking about these little sections here, these little segments between the endpoints. So what's going to happen is you can do this on a graph. So let's go ahead and start by looking at it on a graph. And we know that there's 5 sections that we're going to have to break this up into. And what we care about is this third coordinate here after point A. So if I go ahead and graph this, so 1, 2, 3, 1, 2, 3, 4. So there's A, and then B is 6, 10. So 1, 2, 3, 4, 5, 6. Then up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's B. My goal is to divide this segment here into 5 equal parts. And I care about the third coordinate here so that it's a 3-to-2 ratio. So if I want to divide this into 5 parts, that means I'm going to count the distance, but I'm going to divide it by 5. Kind of like when we do midpoint, we want to divide it in 2 parts. So we count the distance, we divide it by 2. So that's exactly what we're doing here. So if I count the distance, I had to go up 1, 2, 3, 4, 5, 6. So we went up 6 and then over 1, 2, 3. So now your distance here, you're going to break this up into 5 sections. Well, that really means that each of these is going to have to get divided by the 5 parts. And you might be thinking, what I'm thinking is that these numbers are not going to be nice numbers to deal with on a graph. So here's where we can do this algebraically. So I'm not going to actually finish this on the graph because you're going to see that when you actually divide this out, you're going to get decimals that you don't want to deal with on a graph. If it worked out nice, then you could actually finish it up on a graph. You could divide these out and then count those distances. And then when you get to the third coordinate, that would be point P. Algebraically is how most of these problems are going to be. You're going to basically go back to your picture here and you're going to line these up vertically, kind of like how we did those midpoint problems. So you're going to take A, so that's 3, 4. You're going to have 2 points between, and then you're going to have point P. So basically I'm taking this drawing and I'm making it vertical. So point P is what I'm trying to find. So that's going to be my next coordinate, or my third coordinate. Then we have another empty coordinate, and then we have B. So B is going to be 6, 10. So basically what I'm doing is kind of like the midpoint idea, find from A to B. So find that total distance. So from A to B, I had to go plus 3, which we saw on the graph was right 3. And if you divide that by the 5 parts, you end up with 0.6. Which is why on the graph you don't want to actually count that. So over here, what that really means is you're just going to add 0.6 each time. So if you add 0.6 each time, so all I do is add 0.6, add it again, and then when you add it for the final time, you should get back to that number. Because all I did was I divided this, I wanted to break it up into 5 parts, so I divided it by 5. I divided that distance, or that change, that horizontal change, by 5. So then the next piece here is going to be to do the same thing for the y, the vertical change. So I had to add 6, so take the 6 and divide it by the 5 parts. So that means it's going to be 1.2, the change. So again, we didn't want to have to count 0.6 over 0.6 up 1.2 on the graph. That would have been a pain and not practical. So that's why we went over to lining it up and doing it this way. So now I add 1.2 each time. Add 1.2. And you keep doing this process, and you should end up seeing that your numbers work out in the end. So I have 7.6, add 1.2, so I get 8.8, add 1.2, and you end up with 10. So the answer is this point here, this point P, so 4.8, comma 7.6, because this is the point that'll break that line segment AB into a 3:2 ratio. Because remember, this first picture here is so important because that tells you how many coordinates you have in between A and B and where to place point P. So that's the process for this. The other scenario is what happens if you have to find an endpoint and you're given the point that the point that partitions the segment, and also you're given another endpoint. So it's kind of like those midpoint problems. So again, you can look at this on a graph. So I can plot these points and then see if the numbers work. So 1, 2, 3, 4, 5, 6, up to 10. And then 5, 4, 1, 2, 3, 4, 5, 1, 2, 3, 4. And when I look at this, point P is a point that is partitioning this segment into a 2:3 ratio. So see how I'm drawing this dotted line? That really represents that B is going to be somewhere down in here. Because how this is working, if you think about this as a picture, we have A, and then we have 2 parts. That's where point P goes. And then we have 3 more parts. and that's where B is. So if you look at this picture here, really this is 2 sections and B has to be 3 sections long. So B will be somewhere in this region. So you can count this distance and then figure out, if you look at this picture here, we only have 1 point in between A and P. So if I just figure out this change right here, the horizontal and vertical change, to get from A to P, if I divide that in half, that'll tell me this 1 section's horizontal and vertical change. And then once I know that, I can just repeat that process until I get to point B. So on a graph, what you could do is you could count it out. So I could go from A to P. So it's down 1, 2, 3, 4, 5, 6 over 1. So down 6 and over 1. And then if we divide that by 2 parts, because there's really 2 parts between A and P, according to my picture, we could actually end up graphing this. So I could go down 3, but then you're going to go over half. And that's going to get kind of messy if you keep going down 3 over half. I mean, you can do it if you repeat that process. So if I went down 1, 2, 3 over half, 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 and then I have to have one more section. So 1, 2, 3 over half. So see how I have 1, 2, then point P, then I have 3 sections, and then that's my point B. So you can do that with a half, but you can. I'm also going to show you how to do it algebraically. So that would be on a graph. I wouldn't do any other decimals other than 0.5, because 0.5 you can kind of estimate enough. And my picture over here disappeared, so let me sketch that back in. So I have 2 parts to 1, 2, 3. So when I go to line these coordinates up algebraically, I have 6, 10. I have an empty coordinate. I have P, which is 5, 4. I have 2 more empty coordinates. And then I have point B. So point B will be right here. So then from here, remember what we did was we had to figure out, the first step is to find the change in X and change in Y. That's basically the process. So you have to figure out each section. So what you do is you're going to go from A to P. We had to subtract 1, but you're going to divide that by 2 because there's 2 parts between A and P. So that means it's going to be down 0.5. So each time it's going to be minus 0.5. So this is going to be 5.5. Subtract 0.5 and you get 5, and then just repeat that. It has to be the same. So we end up with 4.5, subtract 0.5 again, you get 4, subtract 0.5 again, and you end up with 3.5. Then we're going to do the exact same thing, but we're going to do it for the Y value. So find the change in Y. So you had to subtract 6 for this one. So you take 6 and you're going to break it between the 2 parts here. So that really means you're going to subtract 3. So subtract 3 and you get 7. Subtract 3 again, you get 4, which it should work. And then you just continue that process. So subtract 3, you get 1. Subtract 3, you get negative 2. Subtract 3 again, and you get negative 5. So the coordinates for the endpoint B would be 3.5, comma, negative 5. And remember, on the graph, we got the same answer. We should have gotten the same answer. So 1, 2, 3.5. Then down 1, 2, 3, 4, 5. So you get the same answer, 3.5, comma, negative 5. And I prefer algebraically just because of the decimals, and the algebraic way will always work, but the graphing is kind of a nice visual, so that's why it's good to see it that way, but you don't have to graph these. You do have to be able to do these algebraically because you will often see decimals for the change in X and change in Y. So at this point, you can go ahead and try the check for understanding problems. You're going to see examples that are using the endpoints or giving you endpoints, and you're trying to find point P. So just be careful with that and make sure you find the total change and then divide by however many parts you're breaking it into.